question: what is the possible wavelength of a visible light photon? And options are 500 micrometers, 500 nanometers, 50 micrometers, and 50 nanometers. Micro, it's 10 to negative 6. And you should know that for visible light, wavelength is approximately from 400 to 700 nanometers. And if we are moving to the right, then infrared, then microwaves, and for microwaves lambda is about centimeter, then radio TV, and to the left ultraviolet, then X-rays. For X-rays, lambda approximately, it's called order, it's about 0.1 nanometers, and gamma, for gamma, lambda is about 10 to negative 12 meters. So correct answer is B, it's 500 nanometers for visible light. 2. Masses P and Q are measured to be 30 plus minus 1 grams, and Q is 20 plus minus 1 grams respectively. Which of the following expressions gives the least percentage uncertainty? So we need the least percentage uncertainty, and options are sum, difference, product, and quotient. And we know that for product and quotient, the rule is for the fractional or percentage uncertainty, and the resultant percentage uncertainty is the sum of percentage uncertainties. So it becomes 1 over 30 times 100%, so it's approximately 3.3%, and 1 over 20 also times 100, so it's 5%, and the sum is 8.8% for both. And for sum and difference, there is a rule for absolute uncertainties, and the resultant absolute uncertainty is the sum of absolute uncertainties. So for plus or minus, there will be plus minus 2, and sum is 50 and difference is 10. So percentage uncertainty for the sum becomes 2 over 50 times 100, so it's what is 4%, and it's 2 over 10 times 100, it's 20%. So the least possible percentage uncertainty is for the sum, so 2A. The third question: a car travels clockwise around a circular track of radius r. What is the magnitude of displacement from x to y? So it is moving in a circle from x to y. What is displacement? Displacement is a vector from the starting to finishing point, and it's a radius, and it's also radius, and we can see that the magnitude or the length of this vector is just hypotenuse of this right angle triangle, and it's just r root 2. So r root 2 is C, so C is correct. 4. A car accelerates uniformly, it means acceleration is constant. The car passes point x at time t1 with velocity v1, and point y at time t2 with velocity v2. The distance xy is s. The following expressions are proposed for the magnitude of its acceleration a. So its acceleration is 2s over t2 minus t1, or delta t squared. The second a is v2 minus v1, and both are squared over 2s, and 3a is v2 minus v1 over t2 minus t1 or delta t, and 3 is correct because it's just a definition of acceleration rate of change of velocity, change in velocity divided by change in time. And it's also directly formula, it is given in a data booklet. And what about this? It's seems to be from formula S is ut plus at squared over 2, but u is the initial velocity, it's v1 here, and if we saw, and t is the t2 minus t1 or delta t, and we can see that definitely it's not true because v1 is not 0. It would be true if it would start from the rest. So 2 and 3 it's C, for C. 5. A ball is projected at an angle to the horizontal on Earth, reaching a maximum height h and a maximum range r. It means horizontal distance traveled and some initial speed u at some angle theta to the horizontal. The same ball is projected at the same angle and speed on a planet where the acceleration due to gravity is 3 times that on Earth. So on Earth it's g, on the planet is 3g. Resistance effects are negligible. What is the maximum range and the maximum height reached on that planet? Definitely we can consider law of conservation of energy or formulas, SWET formulas, and how to get the maximum height. It's when vertical component of velocity becomes 0. So let's it doesn't matter angle here, so let the vertical component be u, just uy, and finally so we use formula v is u plus at, so it becomes 0 is uy minus gt. So time to reach the highest point, it's y over g, and using formula S is ut plus at squared over 2, or actually we can use another formula, law of conservation of energy. It becomes uy g minus g t squared minus, because if we consider y to be upward, g is in opposite direction, component is negative, so gt squared, so uy over g u squared and also g squared and over 2, and we can see that it's proportional to 1 over g, and hence if g increases by factor of 3, so height decreases by factor of 3. And what about a range? If we consider horizontal displacement, again formula ut plus at squared over 2, since acceleration is perpendicular, its component on horizontal is 0, so it becomes ux t, where ux is horizontal component of the velocity, and t is again it will be 2 times uy over g, and also this ux, but we need know only that it is inversely, we can see that it is inversely proportional to g again. So it appears that range is also 3 times smaller because u is constant. So 5a is correct. 6. A ball falls with terminal velocity through air. What is correct about the kinetic energy and the total energy of the fall? Terminal velocity, it means that speed is constant and hence kinetic energy is constant. And what about total energy? Total energy is kinetic plus potential. Potential decreases, and it means that total energy decreases, but this difference is transferred into heat or dissipated as heat, or it's just work against friction. So total energy decreases. 6a. Correct. 7. A ball attached to a string is made to rotate with constant speed along a horizontal circle. The string is attached to the ceiling and makes an angle of theta with the vertical. The tangent is t, and it is given. Theta is here. Tension, weight, and the resultant force is to the center, because the net force is the centripetal force. And what is the question? What is correct about the horizontal component and vertical component of the net force on the ball? Net force, question is about net force, and actually this vector, and net force is to the center. It's horizontal because it is moving in horizontal circle. So vertical component is 0, and we need magnitude. And if we consider this triangle, so you can see that theta is also here and theta is also here. And if we consider this triangle, so it's T, it's mg, theta is here, and it's the resultant force. It's not the third force, it's just the net force, or OMA, or resultant force. And we need the resultant force, and just directly from this triangle we need in terms of tension. So we can see theta. So for theta, net force is the opposite. Tension is hypotenuse, so we just consider sine theta. It's F net over T. So F net is tension times sine theta. So 7D, horizontal component T sine theta, vertical component is 0. 8. A block of mass 2 kilograms accelerates uniformly at a rate of 1 meters per second squared, so acceleration is 1. When a force of 4 newtons acts on it, the force is doubled while resistive force stays the same. So there is force, some resistive or frictional force, it's before, and then force is doubled, so it was 4 newtons, now it's 8 newtons, but it's the same. What is the block's acceleration? Yes, so let's consider the second Newton's law before. So net force is 4 minus F frictional and is MA. So it's 2 kilograms times 1, and we can find frictional force directly. It's what? It's 2 newtons. And then it becomes 8 minus 2 is 2, it's mass, times A. So it's 6 over 2, so A is 3 meters per second squared. And 3 it's B, 8 B. It's correct, 9. The input power of an electric motor is 200 watts. It is used to raise a mass of 10 kilograms at constant speed. If the efficiency of the motor is 40%, through what height will the mass be raised in 1 second? So what is efficiency? It's useful work or energy divided by total energy input, or if you consider everything during 1 second, it becomes in terms of power. So useful work is that this object is raised up, and or it gains potential gravitational potential energy, so or it's actually work against gravitational force, it's mgh. And if we consider 1 second, so energy during 1 second, it's 200 times 1. So we consider time 1 second, so it will be height. It will be raised during or in 1 second, and hence divided by energy also in 1 second. And we need just find h, so it's 10, 10 g approximately also 10, so it's approximately 100, so it's a half h, so h approximately 0.8 meters, it's b, 9b. 10. A tennis ball is dropped from rest from a height. It hits the ground and bounces back to a lower height. Air resistance is negligible. What is correct about the collision of the tennis ball with the ground? Elastic because momentum of the system is conserved. And actually, what is the definition of elastic? Elastic is when kinetic energy is conserved, and we don't consider a system, we consider a ball, and a collision. Yes, actually, all parts of system, kinetic energy is conserved, but flow, it doesn't move. So since speed of a ball changes, kinetic energy of a ball changes, so it's not an elastic. A, elastic because momentum of the system is conserved. B, elastic because the kinetic energy of the system is conserved. C, inelastic because momentum of the system is not conserved. And actually, momentum is fundamental law, conservation of linear momentum. It's a fundamental law. When a system is closed, momentum is always conserved. And D, inelastic because the kinetic energy of the system is not conserved. Yes, D because it's actually definition of elastic or inelastic. So inelastic collision when kinetic energy of the system is not conserved. So it's D. 11. The temperature of an object is changed from theta 1 to theta 2 Celsius. What is the change in temperature measured in Kelvin? Since there is the same increment for Celsius for Kelvin, if we consider change in temperature, we can consider change in Celsius or Kelvin. It doesn't matter. But if you meet just temperature in some formula, you should substitute in kelvins only, because Kelvin is SI unit. But for change in temperature, if you convert each temperature into Kelvin, 273 just cancels and you get absolutely the same. So it's easy. It's just theta 2 minus theta 1. It's A. So difference or change in temperature, it's the same in both Kelvin and Celsius. 12. A solid is heated at constant power in an insulated container. The graph shows the variation of temperature with time, and it looks like this. QR, and what is it? It's solid. So it starts as solid, so it is heated up and it melts, so it's liquid. And what is the question? Why is the temperature constant for section QR? A. The intermolecular potential energy of the molecules is constant. It's not correct, because kinetic is constant and all energy supplied is going into breaking bonds. It means increasing of this intermolecular potential energy. B. Kinetic energy is constant. Yes, it's actually correct. See, the internal energy of the solid is constant. It's not correct, because kinetic constant but potential increases. D. The rate at which the solid absorbs heat is equal to the rate at which it loses heat. It's not correct, because it gains energy in the form of potential. So B is correct. Kinetic is constant. 13. Two blocks X and Y at different temperatures are placed in thermal contact with each other until they reach thermal equilibrium. Block X and block Y are of the same material. The mass of block Y is half that of block X. The change in temperature of block X has a magnitude delta T, and the change in internal energy of block S has the magnitude delta U. What is the change in magnitude of temperature of block Y, and change in magnitude in internal energy of block Y? Again, two blocks. And what about, so same material, it means that specific heat capacity is the same. And mass of block Y is half the mass of block X. The change in temperature of block X has magnitude for X is delta T, and the change in internal energy of block X has magnitude delta U. And this delta U, its formula Cm delta T, becomes Cmx delta T. And what is the change in magnitude of temperature of block Y, and the change in yes, definitely if no energy is lost, it means that energy just transferred from one object to another, so this delta U is the same, and it just is transferred from hotter to the object with lower temperature, and change in temperature is described by Cm delta T, and it is equal to Cm y delta T y. And since it's 0.5 mx, we can see that delta T y is 2 delta T x. So delta U is the same, T 2 times, so it's D. 13 D, correct. 14. A wave is polarized. What must notice that must it means 100% guarantee be correct about the wave. It is a options transverse. Yes, it should be longitudinal. Longitudinal cannot be polarized because it's just actually a line. You cannot polarize. It means wave must vibrate in one plane. Standing and traveling. Definitely, it's important that it must be transverse, but transverse may be standing or traveling. Definitely, it's A. 15. Two identical sources oscillate in phase and produce constructive interference at point P. The intensity at P is I. What is the intensity at P from one source? And when they interfere constructively, if each individual amplitude is A, so when they interfere constructively, the resultant amplitude, yes, it's 2A, but intensity is proportional to amplitude squared, so it's 4A squared. And definitely, or in other words, amplitude increases by factor of 2 and intensity increases by factor of 4, and in opposite direction, if we delete one source, intensity decreases by factor of 4, because 1A squared is just one intensity. So for one amplitude A, intensity I, and the resultant intensity is 4I. Hence, intensity is I over 4. So it's D. 16. A group of students perform an experiment to find the refractive index of a glass block. They measure various values of an angle of incidence I and an angle of refraction R for a ray entering the glass from air. They plot a graph of sine R against sine I. So sine R, sine I from air to glass, and Snell's law looks like N 1 sine theta 1 or I is n2 sine R, but n or refractive index of R is just 1. And what is the question? They determine the gradient to be m, and question is which of the following gives the critical angle of the glass. So gradient it's sine R over sine I, and or how to find critical angle. Critical angle it's n2 sine. Critical angle is n1 sine of 90 degrees. So sine of critical angle is 1 over n2, and we need n2 from the previous, and we can see that n2 it's or actually we need 1 over n2, so let's find 1 over n2. It becomes sine R over sine I, and its gradient. So sine of the critical angle is gradient of the graph, and it's m, and critical angle it's arc sine or inverse sine of gradient. It's A, it's correct. So 16A. 17. A standing wave with the first harmonic of frequency f1 is formed on a string fixed at both ends. So it's fixed. And first harmonic f1. The frequency of the third harmonic is f3. And what is f1 over f3? And actually it's just by definition the third harmonic it's how many times frequency of this third harmonic is greater than frequency of the first. So f3 over f1 it's 3 by definition, or you may consider the third harmonic, it looks like this. So definitely it's 1/3. Notice that, let's check 17D, yes, it's 1/3. If you don't know this, you may consider general formula using wave speed and fixed L represent make equation. So initially it's what lambda over 2, because it's half a wavelength, is L together with what formula is what wavelength, it's wave speed times period, so over frequency. So V is lambda f. So V is lambda frequency 1, and lambda here it's 2L, so it's 2L frequency 1, and then the third harmonic, it looks like this. It's what we can see 3 over 2 lambda, which is L now, so lambda is 2/3 L, and V is constant, wave speed is constant, it depends on air, if it's sound, or tension, if it's string. So it's constant, and it's now 2/3 thirds, LF3, and we need what? F1 over F3, it's 1/3. So it's 17, it's D. And remember that if it's open closed, there are possible frequencies which are F1, F3, so the second possible frequency, it is denoted as F3, and it's called the third harmonic, not the second, because again, because of definition, harmonic, number of harmonic, it's a ratio, nth harmonic and the first harmonic. 18. Electricity, two positive charges of magnitude Q and 2Q are fixed as shown. So A, charge Q, B, C, 2Q, and D, positive, plus, plus. At which position is the electric field due to these charges equal to 0? We know that field is from plus to minus and inversely proportional to distance squared. It means the smaller distance, the greater field. And if we consider point D, field is from plus to minus, from plus. So both charges create field to the right at point D, so they cannot cancel. So we cannot get zero field at point D. At A, the same, from plus, the resultant field is to the left, and two vectors to the left cannot cancel each other, so field cannot be equal to 0. And at from plus, so at B from plus, so field created by plus Q from plus to the right, and field created by 2Q is to the left. At C also the same. But what about magnitudes? You can see that 2Q is large and the field is proportional to charge and inversely proportional to distance squared, and charge 2Q is larger, but since distance is larger, it will be balanced by smaller Q and smaller R, so it's B. At C, charge 2Q is larger and distance is smaller, so field due to 2Q will be large and there will be resultant field. So it's B. 18, B. 19. X and Y are two conductors with the same diameter, made from the same material. Y is twice the length of X. So it is given two resistors and Y is 2 times longer. X dissipates power P, so it's X, Y, power P. What is the power dissipated by Y only, not total, Y only? And definitely we need some formula so that we get only one variable, and we can compare some one variable, and definitely this variable should be length. And length is related to what? It's resistance, and resistance is the resistivity length over cross-section area. So resistance is directly proportional to the length, but power it's current times voltage, or current squared resistance, or voltage squared over resistance. But what formula should be chosen? And we should choose such formula so that R is the only variable, but what is constant for both X and Y, current or voltage? We know that in series current is the same, so current is the same for both, and since for P it becomes current squared R, and since L is 2 times larger, for Y it becomes I squared 2R, and we can see that power dissipated by Y is 2P, so it's C. 20. Four identical lamps are connected in a circuit. The current through lamp L is I. 1, 2, 3, 4, and L is here, and current is I. And lamps are identical, it's very important. The lamps are rearranged using the same cell, and it looks like this. And lamp L is here. What is the current through L? EMF is the same, so we can see current is split into two branches. So initially, so current I is also here, here, because they all are identical. So initially its current is 4I, and actually these two circuits are identical, because you can move this branch to this side and it will be absolutely the same. So it's the same, it's I, so it's C. 21. An electron enters a region of uniform magnetic field at speed v. So magnetic field, electron with speed v. The direction of the electron is perpendicular to the magnetic field. The path of the electron inside the magnetic field is circular with radius r. The speed of the electron is varied to obtain different values of r, which graph represents the variation of speed v with r. So let's describe the situation, and we know that force which acts on the charged particle in the magnetic field, it's the Lorentz formula. It's charge QVB, it's magnetic field strength, and since it's a circular motion, it's the net force, and it's the centripetal force, so it's mv squared over r. Q, it's elementary charge, it's E, 1b cancels and it becomes E. V is V over R. So V is directly proportional to R, and it is expected a straight line through the origin. And it seems to be A. 21A is correct. 22. Stuntman rides a motorcycle on an inside surface of a cylinder. Which is the correct free body diagram showing all the forces acting on the cyclist at that position? So there is motion in a circle and a cyclist, and definitely there must be weight, and weight acts through the center of mass, and definitely it downwards. It is downwards, A, B, C, D, and definitely A is not correct. Then since it's not frictionless surface, there must be frictional force, otherwise it will be moving downwards. So friction up, so that it balances weight. So it's not V. And there is and actually, since it is moving in a circle, there must be at least one force which provides the net force to the center, and it's a centripetal force, and this force, it's normal reactions perpendicular to the surface. And it's C. D is impossible if you are moving in a circle, because there is no resultant force to the center. So it's C. 23. The radius of the Earth is R. A satellite is launched to a height, radius R, launched to the height H is R over 4 above the Earth's surface. And be aware such equations, because maybe distances from the center above the surface, but all distances are measured from the center of a planet. So radius is R, and it is launched to a height H is R over 4 above, so R over 4. So finally distance is what? 5R over 4. And question is, what is gravitational force on satellite at the surface to gravitational force on satellite at height H at this point? So what is gravitational force? It's a constant mass of a planet, mass of a satellite divided by distance squared, and we need ratio where at the surface definitely these constants will cancel, and it's just inversely proportional to distance squared, but from the center of the planet. And numerator is force at the surface. At the surface it's just R, but it becomes here because it's 1 over R squared. And at this point it becomes 5R over 4 squared, and it's 25 over 16 is C. 24. The energy levels E on an atom are shown. Like this, larger, larger, and very large difference. One, this one, and this one. And we know that change in energy is proportional to the frequency, and lambda is inversely proportional to the frequency. And which emission spectrum represents the transitions, and since there is one such a transition with what greatest change in energy, so there must be very large frequency and there must be very small, if we compare with other transitions, wavelengths, and we can see definitely there is only D possible. So it's D, and you can see for D that there are three lines in terms of its wavelengths, which are close, which are similar, and it's according to these three transitions. They are close to each other. Okay, 25. 25. Three claims are made about the structure of the atom. Most of the atom is empty space. The positive charge of the atom is concentrated in the small volume. And the third, the electrons have discrete energy levels. Which of these claims can be deduced from the Rutherford-Geiger-Marsden scattering experiment? It's in general, statement 3 is correct, but it cannot be deduced from Geiger-Marsden experiment, but that atom is mostly empty space, and that all mass is concentrated and actually at very small space, and is positively charged. It can be deduced. So 1 and 2 are correct. So it's A. (26). If you don't remember what is Geiger-Marsden experiment, it's a source of alpha particles by it is bombarded a thin gold foil, and it was suggested that charge is uniformly distributed over metal, and it was expected that these alpha particles will be passing through with very small or no deflection, because alpha particles are relatively massive particles. But for some, definitely it was true that the most amount of alpha particles passes by with small deflection, but for some directions these alpha particles were deflected at about 180 degrees, but it can be possible if alpha particle, which is actually heavy particle, meets more heavier particle, and it was deduced these results 1 and 2, but from this experiment you cannot or you can say nothing about electrons and electron and energy levels. Next, 26. I actually don't remember. It may be true that electrons orbiting around, but definitely cannot be deduced about energy levels. 26. A radioactive material has a half-life of 6 days. How long it will take for 75% of a pure sample of the material to decay. And formula is actually you don't need formula, but to understand number of mass or activity, number of nucleus of remaining atoms or nucleons, it means undecayed, its initial quantity divided by 2 to the power of number of half-lives, and for a cell there will be only integer number of half-lives, so it's time divided by t over t of half-life, and we need 75% to decay. 75 decay, it means 25 remaining, or 1/4 remaining, so it's 1/4 of some n0, it's n0 divided by 2 and the number of half-lives. And you can see to get 1/4 there must be 2 half-lives, so that you divide after 1 half-life, half remains, half decays, and after 2 you can see that 1/4 undecayed and 3/4 decayed. So n is 2 or 12 days, and 12 it's C. It's correct. 27. This interaction between the proton and the pion violates 2 or more conservation laws. So proton plus pion plus pion, quark composition of particles, pi minus du hat, proton is what, UUD, k minus su hat, proton UUD, and pi plus, it's antiparticle, it's what, UD hat. And which laws are violated by this interaction? And laws are charge, strangeness, and baryon number. And what about charge? Plus minus 0, minus plus 0. So 0 is 0, charge is conserved, so not violated, so not 1. And actually without 1 it's only option C, 2 and C. But let's check. Baryon number, proton is baryon, so baryon number plus 1, pion is not baryon, so 0, cation not baryon, pi not baryon, so plus 1, is not equal to 0, so baryon or conservation of baryon number is violated. And strangeness, you can see there is only one strange quark here, and definitely strangeness before is 0, after is -1 for strangeness. If there is strange quark, so strangeness, each strange quark provides strangeness of -1, anti-quark +1. But if there are no strange or quarks or anti-quarks on the left hand side and only one on the right hand side, definitely that strangeness is not conserved, and it's C, 2 and 3. 28. A student claims that the following 3 factors may affect the rate of global warming: increased volcanic activity, increased solubility of carbon dioxide in the ocean, increased rate of deforestation. Which factors can increase the rate of global warming? All 3. It's easy. It's oh, just a moment. 3 factors may affect the rate of global warming. Which factors can increase the rate of global warming? Deforestation, yes, it increases global warming, definitely. Volcanic activity, yes, because it will be increased CO2 level or something like that. Yes, yes, solubility of carbon dioxide in the ocean. Yes, it decreases CO2 level in air. Yes, so it will decrease rate of global warming, not increase. So 1 and 3. 1 and 3. So it's B. 29. 2 surfaces X and Y emit radiation of the same surface intensity. Intensity is power per unit area, and it is given formula in the booklet that power is proportional to surface area. It's 4 pi radius squared, and temperature to the power of 4. But if we consider intensity, it will be proportional only temperature to the power of 4, and definitely in general there may be some coefficient which is called emissivity if it's not a black body. Yes, and here emissivity required. So 2 surfaces X emit radiation of peak wavelength twice that of Y. So lambda X is twice lambda Y, and according to the Young's law, wavelength of peak radiation is inversely proportional to the temperature. So if lambda X is greater, it means temperature of X is less. And if the same intensity, it means Ex Tx to the power of 4 is equal to Y Ty to the power of 4, and Tx is less, so product to be the same, emissivity of X must be larger, and we need a factor, and definitely there are 2 options, 2 and 16, and definitely it's 16, but how to show that. Tx is ty to the power divided by 2, but since it's to the power of 4, 16 arises here, and we get 16, so emissivity of x divided by emissivity of y is 16, is D. And the last question. Light of intensity 500 watts per meter squared is incident on concrete and on snow. 300 is reflected from the concrete, so it's concrete, snow, (300) from concrete and 400 from snow. What is albedo concrete? Albedo concrete divided by albedo of snow. What is albedo by definition? It's percent of reflected light. And for concrete it's 3/5, and for snow it's what? 4/5, and we can see that it's 3/4, and it's B. And that's all.